So today we are going to learn multinomial theorem to solve permutation and combination problems. It's basically a technique where we use what we have learned in the binomial theorem lectures to solve problems of permutation and combination. Okay. For example, if you come across a problem like this, let's say a plus b plus c plus d is equal to 15, where a, b, c and d belongs to the set of non-negative integers, right? Belong to the set of non-negative integers. Okay. If a, b, c, d belongs to non-negative integers, then clearly I can say that each of this a, b and c and d should be either greater than or equal to 0. Correct? I can further say that in this question, the value of a, that the maximum value that a can take has to be 15. We will get this value of 15 if we take this combination. So let's say a is 15, b, c and d are 0. So 15 plus 0 plus 0 plus 0 will give me 15. So the maximum value that a can take is 15. Symmetrically, b will also lie between 0 and 15. Similarly, c will also lie between 0 and 15. Similarly, d will also lie between 0 and 15. This D15 case will be, let's say D is 15 and A, B, C, each of them are 0. So we will get again A plus B plus C plus D equal to 15. Okay. To solve this problem, we can use a brute force approach. We can start counting cases, right? Like for example, A is 1, B is 1, C is 1 and D then will turn out to be 12. Right? But this approach is going to be very cumbersome. It's going to be a very long approach. So what instead I am going to teach you today is, I'll say the answer to this question is the coefficient of x to the power of 15 in this series, x to the power 0 plus x to the power 1 plus x square till x to the power 15. Similarly, into, I multiply this entire series, entire summation into x to the power 0, x to the power 1, x to the power 2 till x to the power 15. Similarly, I multiply it again with the same thing. I will tell you right now why I am doing this, right? So just bear with me for a second. I am saying the answer to this question is the coefficient of x to the power 15 in this expansion. Okay. Now first let's understand why. These powers that you see 0, 1, 2, 3, 4, these powers are nothing but the different values that a can take. These powers are nothing but the different values that a can take. These powers are nothing but the different values that B can take. These powers are nothing but the different values that C can take, and the power of the last bracket is nothing but the different values that D can take. For example, I want to find out what is the coefficient of x to the power of 15. That means I want to know in how many ways can we multiply these and get to x to the power 15. For example, if I select x square from here, if I select x to the power 5 from here, if I select x to the power, let's say 1 from here, so what I am left with from here, I need x to the power 7. Let's see, 2 plus 5, 7, 7, 7, 14, 14, 1, 15, yes. If I take x square from this bracket and multiply it with x to the power 5 from this bracket, take x to the power 1 from this bracket and multiply x to the power 7 and multiply all these four terms, we'll arrive at x to the power 15. In other ways, I am saying that the value of a could be 2, the value of b could be 5, the value of c could be 1, the value of d could be 17. This is just one way to get x to the power 15, or in other words, you could say this is just one way such that a plus b plus c plus d becomes 15, right? Okay, do you understand? In another way, for example, x to the power 0 gets multiplied with x to the power 0, and this x to the power 0 gets multiplied with x to the power 0. So we have 3x to the power 0 which is getting multiplied with each other. So to get x to the power 15, we would have to multiply x to the power 15 from here. So 0 from here, 0 from here, 0 from here, and 15 from here, which is basically saying that value of A is 0, value of B is 0, value of C is 0, and value of D is 15. Okay? So the number of ways in which we can form x to the power 15 is basically the answer to this question. Okay? You see, each and every term of all these four brackets will multiply with each other. And the highest coefficient that you will get is of course 15, 15, 15, 15, 60 you will get the highest coefficient, right? So how many ways can we form x to the power 15? Okay? Okay? Do you understand this? This is very important. This is the crux of this chapter. Okay? So, to proceed further with this question, I can clearly see that all these four brackets have a GP inside them, a geometric progression inside them, right? So, basically, I could use the formula for sum of GP. It's a finite GP. You could see there are 16 terms in each bracket, right? 0 to 15, 16 terms. As we know, the formula for finite GP series is A into 1 minus common ratio to the power number of terms by 1 minus R. Okay? Sum of a finite GP. Okay? And we also know that the sum of an infinite GP, provided that common ratio is, the mod of the common ratio is less than 1, of an infinite GP is basically nothing but first term divided by 1 minus common ratio. So I could easily see that this formula is much simpler than this formula, right? So if I could convert these finite GPs into infinite GP, my question would become easier to solve. Now let's say after this x to the power of 15, I add another x to the power 16. Will it make a difference to my coefficient of x to the power 15? If I add an x to the power 17, it may get multiplied with this x to the power 0, and this further could get multiplied with this x to the power 0, and this further could get multiplied with this x to the power 0, and what we would get is 16 plus 0 plus 0 plus 0, which will give me x to the power 16, not x to the power 15. What I am trying to say, in any combination if you try with x to the power 16, you will arrive at a power of x which is greater than or equal to 16. You will never get a power of x which is 15, right? So I could do this thing. Further, if I add x to the power 17, it wouldn't make a difference because the minimum power out of x to the power 17 that I would get would be 17 and not 15. The coefficient of x to the power 15 won't change. Okay? So I could say this entire answer will not change if I slightly tweaked this series and made it such. The answer is still the coefficient of x to the power 15, but this time I will start with x to the power 0, x to the power 1, x square, and instead of stopping at 15, I will continue and I will go till infinity. Because all the higher powers after multiplying with x to the power of anything will give me a power which is greater than 15. So the coefficient of x to the power 15 will not change. Okay? So as the same thing I can do with all the three brackets, right? So total 4 brackets I get this. Okay, do you understand? Higher powers will yield a power which is greater than 15, not x to the power 15. So the coefficient of x to the power 15 won't change, whether it is this series or the previous one. Okay? So now this formula becomes easier because this is an infinite GP. As you can see, the first term is this one, which is x to the power 0, which is just 1, right? So this thing becomes the same as 1 plus x square till infinite terms to the power 4, which becomes the same as a by 1 minus r, right? So, okay, and this thing I can write like this 1 minus x to the power minus 4. The coefficient of x to the power 15 in this is equal to the coefficient of x to the power 15 in this is equal to coefficient of x to the power 15 in this. Okay? And this series expansion we have studied earlier, 1 minus x to the power of minus n, where n is an integer, a positive integer, right? So if we want x to the power 15, we know it will come something like x 15. Then I will have c 15. And then on top of c, I will have to write n plus 14, right? This is what we have learned. N plus something, 1 less than this number, right? And what is n in this case? N is nothing but 4. So what I am left with this is 18c 15, right? The coefficient of x to the power 15 is nothing but 18c 15. So that is my final answer. See, I didn't have to count the cases. I didn't have to do anything. I just arrived at the final answer using multinomial theorem. This is what multinomial theorem is. Alright? Okay? You understand it now? Shall we proceed with a different example? Okay. This one I will do a bit fast, right? Because you try to follow. So let's start with a different example. So this time I will phrase the question differently. I will say the question is, find the number of ways of distributing $15 identical toys among 4 children. Let's say 4 boys, such that each boy gets a minimum of 2 toys. Okay? Minimum of 2 toys. Now this question looks like a permutation combination question, right? So I will convert this question into something like the previous one. So let's say the first boy gets 8 toys. Second boy gets B toys, right? Similarly, third boy gets C toys. And the last boy, the fourth boy, gets D toys, okay? Then the sum of the toys that each of them get, if you add them up, it should come to be 15, because there are 15 identical toys. This identical word is very important in this question, okay? So there is no difference between the toys, all toys are same, okay? The boys are different, but the toys are same. So we are distributing 5 identical things among 4 different entities, 4 different boys, okay? So in this case, I will say each boy gets a minimum of 2 toys. So A has to be greater than or equal to 2. Okay? And what is the maximum value that A can take? Let's say, what is the maximum? If in order to make the first boy get the maximum number of toys, the other 3 boys have to get the minimum number of toys. So let's say this is 2, this is 2, this is 2. Then A would get 9 toys. See, 9 plus 6 will give you 15. So the maximum number of toys A can get is 9. The same thing will happen for B and C and D. Okay. So now I will say the answer is coefficient of x to the power 15 in this series. So last time I started with x to the power 0 because the value of a could be 0. Then it was x to the power 1 because the value of a could be 1, if you remember the last question. In this question, the value of a cannot be less than 2 or b or c for that matter. So I'll start with this x2 plus x3 and I'll put in the maximum value of a, that is x9. And you can see the same thing is for b and c and d as well. So this same bracket will appear 3 more times in multiplication. So basically I can say the power of 4, right? Okay. In this series, if I take out x square from this entire bracket, x to the power 8 will come out, and what I will be left with is 1 plus x square till x power 7, right? Okay. So I have to find coefficient of x to the power 15 in this, or in other words, I have to find the coefficient of x to the power 7 in this bracket. 1 plus x square till x power 7. Whole to the power 4. If we have whole to the power 4 here also, right? Yes. Why? Because in order to make x to the power 15, we already have x to the power 8. Right? So what is left is x to the power 7. Right? So if I get x to the power 7 from this bracket, this entire thing to the power 4, multiply it with x to the power 8, it will automatically become x to the power 15, and that is what we are looking for. Okay? Correct? So again, let's see. So this bracket, if you see, to the power 4 means this bracket is getting multiplied 4 times. So, for example, if I add another term x to the power 8 in each of these brackets, let's say if I do it, x to the power 8 multiplied with anything, 1 or x square or x cube or x4, will give me a power greater than or equal to 8. It won't give me x to the power 7. Right? That means the coefficient of x to the power 7 in this question and in this question, whether x to the power 8 is present or not, is same. So instead of finding out coefficient of x to the power 7 in this series, I will find out in this series, and not only in this series, I will extend it till infinity, because the formula of infinite GP is much simpler, right? That's right. Okay, clear? So what I will do is I will extend this series till infinity and find the coefficient of x to the power of 7. Okay. So let's see what the answer turns out to be. Now I know this series is nothing but, let me just chalk. This series is nothing but a by 1 minus x to the power 4, right? Because the coefficient, the common ratio is x, right? So this is nothing but 1 minus x to the power minus 4. And I have to find the coefficient of x to the power 7 in this, okay? So I will write it on top because I am running out of space. This is again that same standard series that we know the expansion to. We should have learned it by now, right? If you want x to the power 7, something C7 will come, and on top of C we will write n plus 6, 1 less than 7, right? And what is n? N is 4. So 4 plus 6 will give me 10C7. The coefficient will be 10C7, or you can say 10C3. Answer is 10C3. Whereas 10C3 ways, and we can always convert it into a number, right? It's basically nothing but 10 factorial divided by 3 factorial and 7 factorial. Okay, if you have to give the answer in this form, this is what the answer would look like. Clear? So this question, which is a question of PNC, we converted into something which comes under the purview of multinomial theorem. Okay? So this is how we use multinomial theorem to solve permutation and combination problems. The important part to note is that multinomial theorem works only when we are distributing identical objects among different entities. Right? If these 15 toys would be different and not identical, this method would not work. Only possibility that we would have would be to form cases and count those cases, which would be a lengthier problem, of course. Right? So as far as JE is concerned, this is the kind of problem you should expect in the paper. Okay? So that is what I wanted to tell you about multinomial theorem. So thank you for listening to me, and we'll see you tomorrow. Okay.